Hello everyone. In this video, I'm going to talk about multithreading in Python. Multithreading in general is the ability to run multiple threads concurrently. The textbook definition of a thread is the smallest sequence of programming instructions involved in a process. Threads allow us to write programs that can execute various tasks at the same time. However, it's important to note that in Python, we do not have true multithreading. This is because of something called the Global Interpreter Lock, or GIL. I don't know if that's how you're supposed to say the acronym, but that's how I'm going to say it for the sake of this video. What the GIL does is lock the runtime down so that only one thread in a single Python process can run at a time. The reason for this was ironically for the sake of speed. By restricting a Python process to one thread at a time, we avoid having to worry about a lot of computationally expensive locks, and it makes managing the required locks a lot easier. The exception to this are read-write operations. The GIL will be released for those. For this reason, multithreading is best used for IO-bound operations for things like files and networking. Let's start with our first example. For this example, I have a function called threadedCount. It takes in two parameters, name and count. We're going to create threads that runs this function. So the primary thing we need to use threads is to import the threading module here. This will allow us to access the thread class. All this other stuff is just some extra things that will help out with our program. Colorama is a built-in module that will provide colors and styles as well as functions and classes that helps us apply those things to the text we print out on the screen. The reason I import the OS module is so that I can use the getPid function, and that's going to be important for demonstrating how these threads function and behave when we run them. And then finally, I import the time module so that I can access the sleep function. That's going to be pretty important to help demonstrate how these threads function as well. So let's just talk about what our threadedCount function is going to do. So the first thing it's going to do is it's going to get our process ID and print it out on the screen for us. And we're going to have it print out in red so it's easier to identify it before we start printing out a whole bunch of different text. Then we print out that the thread has started. And both of these print statements, we're using the name parameter to reference the thread by this name, which as you can see here, we're going to call it first counter and second counter. So we're going to call it the first counter thread and the second counter thread. Then we enter a for loop and we loop through a range, which is defined by the count we pass in. And basically every single time we go through the loop, we just print out a message saying that we've gone through the loop X number of times up until we've reached the count. And after we print out the message, we sleep for 100 milliseconds. Now, sleeping in a thread is not necessary. We don't have to have that. The only reason I implement sleep here is simply so that it's easier to see the thread's behavior, especially when we have multiple threads running at the same time. Because when I was first building this code and I tried running it without the sleep function calls, it basically still looked like we were executing a normal linear program. It was hard to tell that they were all executing concurrently. And then once we exit the for loop, we just print out that the thread's been completed and then it leaves the function. When we leave the function, the thread has ended. So down here in our main program, we're going to print out the main process ID for the main function. And the reason I'm doing this is so that we can compare the main process ID with the thread process IDs. Then we create two thread objects, and I'm going to call them T1 and T2. And when we create thread objects, we specify two named parameters, target and args. We need these two at the minimum. Well, we need target at the minimum. I think if args is empty, you don't have to pass it in. It will just be blank by default. So for target, we specify the name of our function, and it's important to specify it without the parentheses, because if you add the parentheses, then it's just going to execute that function and then assign the result of that function into target, which is going to cause the program likely to crash. So make sure you put the name in there without the parentheses. Then, if we need to, we specify args, and args has to be in the form of a tuple. So for my two threads here, I have first counter and second counter as the name. And then for the count, I've assigned them both to the value of 10. Then to start our threads, we say T1 and T2 dot start. This will cause the threads to execute. And if they have any print statements, they will just automatically print to the screen. And then while those threads are running and counting up to 10 up here, our main thread is also going to loop through 10, and it's also going to count 10 times. And then it's also going to sleep for 100 milliseconds. So we're going to see the main program as well as the two threads run concurrently with each other. And then down here where we say T1.join and T2.join, that's how we end those threads. What join does is it waits for the threads to finish executing, and then once they're done, it will merge the thread with the main thread or the main program. So that's basically how you close the threads out. And it's for that reason why you have to make sure that you have a way of closing those threads when necessary, because you can have very complicated threads and you can have threads that are like running indefinitely because they're designed to continuously wait for data or process data until they got some kind of kill switch value set to end them. In which case, if you don't handle that correctly and you just try to join the thread and it won't stop, then your program will be stuck running indefinitely until that thread somehow dies. So that's something to keep in mind when you're creating threads, is to make sure functions can definitely end so that when you call the join function, they will end and you can close your program out. So I'm going to run the program here. So the first thing you notice here is our process IDs. You can see that they are all the same, and that's because they are running under the same process. They might be threads that are separate tasks that are executing concurrently, but they're part of the same Python process, so they have the same process ID. And then you see them starting and they're printing out their numbers and they're counting and everything like that. So we've got first counter counting 0, their second counter, main thread counting to 0, then 1, then first counter and main are alternating between each other. Sometimes one thread will get 2 executions in before it switches over to the next thread. Sometimes it will only get 1 execution in. And as you can see here, the order is not guaranteed too, because you got main first, second, then main second, first. So it's not going to be the exact same order that each thread gets a turn to perform its execution. It really varies. Of course, with this, there's sleeping involved, so it's easy to see them take turns. But for other programs where you've got complex tasks going on and they're probably doing a whole bunch of stuff, it really vary on which thread is getting more executions out and which thread goes next in line and everything like that. Threads are not limited to running functions. We can create classes that inherit from thread. In order to define a class that inherits from thread, we just need 3 things. 1, it inherits from thread, obviously. 2, if you define the init method for your own class, it must include a super.init call. It must call the parent class's init. And 3, it must have a defined run method. As long as you have these 3 things, you can create a class that inherits from thread to create thread objects. So for this example, I have the docHandler class, which is going to inherit from thread. I have defined its init method, which contains 3 parameters: name, color, and queue. And then down here, as you can see, I store these parameters into some attributes for the object. But you also may have noticed that I have a running attribute that's automatically set to true. If you recall from the previous example, I mentioned something about making sure that your threads are able to end. Sometimes you might have something that is a thread that has no defined end, and so it doesn't know how to end on its own. It needs something from the outside to tell it to end. So I'm going to write this object to act like that so I can show you one of the ways you can handle that. In this case, it's monitoring a variable called running. Then we get to the actual run method, which is what's going to be executing when we start our thread. So as I mentioned, we're going through a while loop, making sure that self.running is set to true. And as long as it is, we're going to be checking our queue. That's what we passed in here. What we pass into the queue parameter when we create these objects is one of these 2 lists right here, doc1 queue and doc2 queue. What these queues serve for is basically a data queue. When data gets added to these queues, the run method is going to work on that data. So when it sees that queue is empty, it's going to sleep for 100 milliseconds, then continue and go back to the top of the loop and check again. If there is data in the queue, it will go down here, pop the first item in the queue and store it in next. And then it's going to print out next. It's not going to do anything special or anything like that. It's just going to print it out. And then as you can see here, it's going to color it. So each thread is going to have a different color so that we can tell the threads apart when it runs. One thread's going to be yellow, the other one's going to be blue. And then it's going to sleep for 100 milliseconds, go back to the top, and then repeat the process. So what is adding the data to the queue? Which brings us to our main function down here, where our main thread is going to be running in this multi-threaded program. So the first thing we do is we create our 2 threaded objects, and we assign them doc1 and doc2 for names. Doc1 gets a light blue text color, and doc2 gets a yellow text color. And then we assign the doc queues that they will be monitoring to print out their messages. And then we start the threads using the start method because they inherit from the thread class, so they have access to that, as well as the join method too. Then the main thread will do these 2 for loops here. Both these loops are doing the same thing. They're just basically appending messages to either the doc1 queue or the doc2 queue, so that when the doc handler sees those messages get added to the queue, they can then print them out. The first one is basically printing out that ships are being docked, and the way it's doing it is it's splitting it evenly. Even numbers will go to doc1, odd numbers will go to doc2. And then down here, it will print out that ships are departing. Then down here, we wait for the queues to be fully empty, so it's going to let the threads continue running and continue to print out the messages until there are no more messages to be printed. And then once that happens, it will leave the while loop. Then it will go down here, and we see our attributes that we're using as the kill switch, and we set them to false for both threads. This will allow for this loop to break out, thus ending the thread program, because it can finally get to the end of the run method, and that'll end the thread. And when that happens, when we call the join methods for both objects, it will join the threads with the main thread, and then the program will end. So when I execute this, so we're seeing them all get printed out, and it's pretty uniform, blue, yellow, blue, yellow, blue, yellow. In some cases, depending on the speed of the whole printout and how many numbers there could be some variations. You could sometimes see some blue, 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 or yellow, 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 or something like this. But for this particular script, it's going to be blue, yellow, blue, yellow, blue, yellow, because it's pretty uniform, especially since they're just evenly alternating the numbers between the two doc queues. And for our final example, I'm going to demonstrate the use of a pool. A pool makes it easier to manage multiple threads or processes at a time. For this example, I've got two functions that will be run through threads. Threaded count, which takes one parameter, and named threaded count, which will take two. So they're both pretty much doing the same thing. They're just counting. The main difference is that the named threaded count will print out the name, so you'll get a little bit more specific information. And it's important why I'm doing it this way. You'll see why in a little bit. So the first thing we're going to do is we're going to create our pool, and I'm going to set the parameter processes equal to 2. This basically says that the pool can only execute 2 processes at a time. In our case, 2 threads at a time. And then for our first demonstration, I'm going to show you how to use the map method for the pool. Map at the minimum takes a function name that we're going to have executed inside the threads, and then it can also optionally take a list of arguments. Now, for map, it will only be able to really execute functions that have only one parameter at the most. If it has more than 2 parameters, we can't use the map method. I've tried various different ways of trying it out until I went online to look it up for myself, because I rarely use threads, much less pools. So it seems like map cannot directly handle functions that have multiple parameters. But don't worry, there's a way to handle that, so I'll show that later on in this example. In this case, it can only take 1, and we have to put the arguments for its single parameter in a list. So by specifying threaded count, followed by a list of 2 numbers 10 and 20, I'm basically telling map to create 2 threads of threaded count, one that will count to 10 and one that will count to 20. Now, if we wanted to create a bunch of threads in our pool that could potentially be pointing to different functions, or maybe even the same function but with different parameters, or even functions that have multiple arguments, then we would use the method apply async. I've got 2 examples for apply asynchronous, one that just gives a general idea of how asynchronous works, and the second one is going to demonstrate how to use it to handle functions that have multiple parameters that need to be passed in. So the first one, we're just showing it off. We're adding 2 threads to our pool, and what apply asynchronous returns is something called an asynchronous result, which we have to have stored in a variable when we create it, because it's that variable how we access the actual thread being run. I basically just use threaded count for both of these, but I specified different numbers like before, but in this situation, we're specifying tuples, not lists. This is what allows us to pass functions with multiple parameters into our pool, because we can now use a tuple with multiple values to represent each parameter. Then once we get our asynchronous results, I will then put them in a print function here, and I call results.get and results1.get, and inside I specify a parameter timeout equal to 1. I don't think you need to specify the timeout by default, but I specify it here. And it's important to note that despite how linear this code looks and how it's being executed, when the actual threads get executed, it will be concurrent. And then down here, I show how you can use apply asynchronous to run threads for functions that take in multiple parameters. So the first thing I do is I create a list to store our asynchronous result objects. And then I loop through a list of arguments that are stored in tuples so that I can create those asynchronous results by constantly calling apply async to the named threaded count function, but with each argument set that I have for it. So we will have 3 asynchronous results stored in this list here. And then down here is where we loop through the list of our asynchronous results to actually see the results get executed. So I just loop through the list and I call .get timeout equals to 1 for all 3 asynchronous results, and we'll see the threads execute. So I'm going to run it. So here's our first part of the example, which is up here. We just create 2 threaded count threads, one counting to 10 and one counting to 20, technically 9 and 19 because it starts at 0. And as you can see here, they actually have different process IDs. So I have no experience with pools really. I know how to use them in general. I don't have enough experience with them to fully understand how they actually operate. So it could be, even though we're using threads for these pools, that it's actually generating separate processes. What that actually means for whether or not these are actual threads, because that could mean that they're not able to share the same immediate variable resources as the main thread. So like in the second example where we had those 2 docking lists for the output, it may not be able to work the same way if you use a pool for that. That's my assumption. I could be wrong on that. I don't have that much knowledge on pools to fully understand how this is working, but they do have different process IDs. So we see the 2 threads start and they're counting to their respective numbers, and then they get completed. And as you can see, the process IDs assigned to these threads are the same as the ones that were assigned to the threads in the previous one, as well as in the one right here. So what that also tells me is that when, at the very least, when you specify a max number of processes to run in a pool, it likely pre-allocates process IDs to be used for these threads. But like before, it's just simple counting. So they're counting to 4 and 5 respectively, from 0 to 4 and 0 to 5. But you may have noticed down here that it prints out none. And the reason being is that when you execute the asynchronous result, it's actually printing out the return value of your function as well. And since functions return none by default, it's going to print out none. If you specify a return and say like true or some string or a number, it'll print out that instead. And then down here is our last bit where I show you how you can use apply asynchronous to execute functions that take in multiple parameters. So you see the first 2 threads start almost immediately. The third one doesn't start until down here. And that's because the max number of processes that the pool can execute at a time is 2. So as soon as one thread finishes, that process ID will be assigned to the third thread, and then the third thread will execute. And in this case, it looks like thread 2 finishes first, so thread 3 gets its process ID. So that's how you would execute a function in a thread that takes in multiple parameters using a pool. And that's pretty much it for the basics of multi-threading in Python. So I hope you've enjoyed this video and found it helpful, and if you did, then please hit the like button and leave a comment below to let me know what you think. And if you want to see more, head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.